Assalamualaikum, nama saya SB Safia binti Mim Asman. Nombor metrik saya 01DDT23F1106. Jadi hari ini kami akan membentangkan jawapan kami buat mini projek untuk subjek data structure. Saya akan bentangkan jawapan untuk soalan 1 dan soalan 4 B. Untuk soalan 1, Aiman joined a programming competition in his faculty. He was given 1 week to solve a problem. Aiman asked for your help to construct a program to reverse the word that entered the program. For example, if users enter ALI, the output will display ILA to the screen. Aiman wants you to use stack to store the inputs. Jadi ini adalah coding untuk soalan 1. Kami menggunakan C++. Jadi kat sini kita masa kita mula-mula buat program, kita kena tulis include iostream dengan include string. Lepas tu using namespace std. Okey, lepas tu kita nak fokuskan dekat dia punya coding dia sendiri. Jadi kat sini kami menggunakan structure. Untuk stack menggunakan type def. Jadi type def struct word. Word ni adalah nama stack tu. Lepas tu stack ni pula adalah dia adalah structure variable. Jadi kita buka benda ni, kita akan pergi ke satu-satu. Jadi kat sini kita ada declaration untuk size stack tu iaitu 30. Kemudian kita ada array untuk simpankan stack element tu. Jadi max size dia adalah 30. Jadi maksudnya char array ni size dia adalah 30. Lepas tu kita ada in top ni, dia adalah untuk index untuk top element tu nanti. Jadi kita move on kepada kepada function top stack. Top stack ni dia akan simpan nilai top bersamaan dengan -1 untuk menunjukkan stack tu adalah kosong. Kemudian kita ada is empty. Is empty ni pula dia periksa kalau stack tu kosong ke tak. Kalau dia kosong, dia akan returnkan top bersamaan dengan -1. Kemudian kalau kita nak check stack tu penuh pula, dia akan ada satu lagi method iaitu is full. Dia akan return top bersamaan dengan max size tolak 1. Jadi max size kan 30. Jadi 30 tolak 1 bersamaan dengan 29. Kan array kan dia sampai index 29 kan, untuk full array sampai 29 saja. Jadi kalau penuh dia akan keluar method ni. Okay, moving on. Kita ada pula untuk push character tu dalam stack, kita ada void push. Parameter dia adalah char ch. Jadi dia panggil, dia guna if selection tu. So dia panggil is full. Jadi ni kan, dia panggil ni balik. Jika kalau penuh, dia akan keluarkan statement ni. Tapi kalau tak, dia akan return saja. Lepas tu ada array, lepas stop equals to ch. Kemudian kita ada function pop. Jadi pop ni dia untuk pop character daripada stack tu. Jadi kat sini dia ada if else selection. Jadi dia cakap if is empty, see out statement stack underflow. Maksudnya kalau dia kosong, dia tak ada, dia stack yang kosong, dia tak ada apa-apa nak pop. Lepas tu kalau tak, dia return saja. Kemudian ada return array top minus. Maksudnya array ni dia nilai top, kemudian dia berkurang. Kemudian ada nama dia stack ke sini. Okay. Lepas tu kita pergi pula kat sini. Function untuk reversekan perkataan tu menggunakan custom stack. Jadi kita ada string reverse word. Dia punya parameter dia adalah string word. Jadi kat sini kita guna structure variable dia, stack ni. Lepas tu kita letak nama char stack. Jadi sekarang kita tulis char stack dot top stack. Itu untuk create stack mula-mula. Kemudian kita push each element of the word into the stack menggunakan for method, menggunakan for loop. Jadi jika size t I equals to 0, I lebih kecil daripada word dot length, kemudian plus I, char stack dot push word I. Maksudnya dia masukkan setiap karakter daripada perkataan yang kita input tu nanti. Kemudian ada string reverse. Ini untuk popkan setiap karakter daripada stack tu untuk membina perkataan yang terbalik tu. Jadi selagi char stack dot is empty, tidak not, dia akan reverse equals to reverse tambah char stack pop. Maksudnya yang perkataan karakter yang kita pop tu dia akan masuk dalam variable reverse ni. Kemudian kita return ke reverse. Kemudian kita pergi ke main function je pula. Kat sini string ada string word. Kemudian kita masukkan apa-apa perkataan yang kita nak. Kemudian string reverse word akan simpan nilai, dia panggil function reverse word, dihantar parameter word tu. Kemudian kita coutkan reverse word dan itu sajalah. Sekarang saya akan tunjuk demo. Contohnya kita masukkan perkataan Jabal. Jadi kita keluar Lamash. Yang itu saja untuk soalan 1.
Hi, Assalamualaikum. So this is answer for question 2. Let's look for the input first. Here's the input. For order note, the structure represents an individual order. It contains a string for the order description and a pointer to the next order in the list. For customer note, this structure represents a customer. It includes a customer's name, a pointer to a stack of order, and a pointer to the next customer in the queue. It also has method to push and pop order. For order management, the method in customer order allow adding a new order to the customer stack. The pop order method retrieve and remove the most recent order from the stack, returning the order description. Next, for order queue class, this class manages a queue of customer. It has pointer to the front and rear of the queue. For add customer, this method adds a new customer to the queue and initialize their first customer. Their first order. And next, add order to customer. This method allows adding additional order to an existing customer by searching through the queue. For process order, this method processes all order for each customer in the queue, printing out each order as it is prepared and deleting the customer note once all their orders are processed. For destructor, the order queue destructor ensures that all dynamically allocate memory for customers and their order is properly released when the queue is no longer needed. For the main function demonstrates the usage of the order queue class by adding customer and their order, then processing those orders. Overall, this program illustrates fundamental concepts of data structure in C++, such as linked list and dynamic memory management, while providing a practical application for managing customer order in a queue format. So, let's see the last part, which is the order queue for order queue. So, bila kita tengok kat sini ada order queue, add customer. Dalam bracket ada the customer name and the order. So when we see here, we can understand how the output boleh keluar. So bila kita tengok output kat sini, kita dapat tengok order for Alice, order for Bob and order for Charlie. That's all.
Hello everyone, today we will be presenting our mini project which is on data structure. My name is Jayshin Selvakumar, 01DDT 23F1192. So my question will be the good question, which is write a C++ program to show implementation of binary search using linked list, and your program must include basic operation in binary search tree including create BST, inserting items into BST, deleting items from BST, and display data in BST. So let's see. What is BST? BST is a binary search tree, is a node-based data structure where each node has data, left child and right child. So the data is the value stored in the node. Left child is points to the node with value less than the node's value, and right child points to the node which value greater than the node's value. So they are to create a BST. If we see the creating code, you can see that is data, which is int value, and data actually holds the integer value for the node, and left, which is left child node, a pointer to the left child of the node. All right, and right is a pointer to the right child of the node. All right, and constructor. Okay, initialize the nodes and data with a given value and set the left and right pointers to null ptr, or as you see. All right, so in BSD, all values in the left subtree of a node are smaller than a node's value, and all values in the right subtree are greater than node's value. As you see, it's the main point of BSD. Okay, so let's see the code now. Okay, they asked to create the node. So as you see, create node's main point will be node star create node, and then int value you have to input the value, and node times new node arrow data equals to value, new node left and new node right ptr, return new node. That would be a code to create BST. All right. All right. So next, insert BST. So the insert function adds a new node specific value to the BST while maintaining the BST's properties. So if we see the node, the if we see the code, the parameters would be root and value. So what is root? Root is the root node of the current subtree, and value would be the integer value to be added into the BST. And let's see about the process too. Okay, if root is null ptr, it means that we have found an empty spot in the tree, so we can create a new node with the value and return it as the new node. And if value is lesser than root arrow data, the function is called recursive to insert the value in the left subtree. And if value value is greater than root arrow data, the function is called recursively to insert the value in the right subtree also. So return would be the function returns to the modified subtree's node, as we see. Yeah. Okay. So next is delete BST. Okay, the delete node function removes the node with a specific value from the BST and adjust the tree to maintain BST properties. So if we see, this would be the deleting nodes, deleting BST's code. So the parameters same, which is root and value, and the root node of the current subtree and the integer value is to be deleted. So the process, search for the node. So if the value is lesser than root arrow data, and recursively call delete node on the left subtree. So if value is greater is recursively call delete node on the right subtree. So uh, there is also case 1, case 2, and case 3. So in a delete BST, node has no child, which is also mentioned by Leaf, is delete it and return null PTR. That would be the case 1. And case 2 would be the node has one child. So delete the node and return its single child. Case 3 is node has two children. So find the in order success and replace the current nodes with the successors values, and then delete the successor. So and then lastly it would be the return. The function returns the modified root of the subtree after deletion. All right. So next is display BST. So if we see display BST, it's also an in-order traversal. So the in-order function prints the BST in sorted order by performing an in-order traversal, left to right. So as we see the code, and the process will be the recursively visit the left child, then the current node, then the right child. So and then it prints each node's data in ascending order as per PST's property also. All right. So next we will see about the full code.
This is the code that I have did in GDB compiler, and as you see, I have explained the code in the previous slide, and you can see include iOS stream using namespace std is a must in a C++ code, and start node in data. It will be defining and creating a node. Node int value, data value, left, right, null, ptr. It's creating a BST, and then we have to insert a BST, which is node star insert node star root input value if root is equals to null ptr, and everything I have already explained. And this is the minimum value of node. If we have to count the minimum value, you have to use this code, which is node star minimum value node, then node current equals to node while, and then return current. So to delete a node, you have to use this code and in order. So in order code would be this, and this would be the elements that we have include in the code, which is inserted values 50, 30, 20, 40, 70, 60, and also 80, and C out. In order traversal, we have to output the inner order traversal, and deleting 20 divide n. So to delete a node, and this would be the compiled code that I did. And so let's see the output.
For question 4, based on figure below, illustrate the steps to find the target key of 52 by using the linear search method and binary search method. The number given is 8, 11, 19, 25, 34, 47, 52, 55, 58, and 60. So for linear search, you need to compare index with the target key given. So first compare index 0, 57 and 47 and 52. So the answer that you get is 47 not equal to 52. Next, compare index 1, 19 and 52. The answer that you get is 19 not equal to 52. Next, compare index 2, 34 and 52. The answer that we get is 34 not equal to 52. Next, compare index 3, 52 and 52. The answer that we get is 52 equal to 52. So the match found.
Saya akan teruskan dengan jawapan untuk part B. Jadi kita kena cari elemen 52 menggunakan binary search. Jadi mula-mula kita kena dividekan search space tu kepada 2 dengan mencari index middle dia. Jadi kat sini index middle dia, elemen dia adalah 47. Jadi 47 ni dia lebih kecil daripada 52. Jadi kita memandangkan 52 lebih besar daripada 47, kita akan teruskan pencarian kita ke sebelah kanan. Jadi kita teruskan. Jadi sekarang kita elemennya search space kita adalah 47 sampai 60. Jadi sekarang middle dia adalah 55. Jadi 55 ni lagi besar daripada 52, maka disebabkan 52 ni lebih kecil daripada 55, kita bergerak ke sebelah kiri dia pula. Jadi sekarang elemen dia adalah 47 dengan 52. Jadi sekarang dia punya middle antara dua ni adalah 47. Jadi 52 ni lagi besar daripada 47. Jadi kita bergerak pula ke sebelah kanan. Kemudian kita jumpa pula, so kita dah sampai sini, kita dah jumpa dah elemen 52. Maka kita sudah capai apa yang kita mahu lakukan. Jadi itu sahaja.